Just go?
Yeah, you're good to go. Go ahead and kind of, take your giant leap.
Can we touch it?
What would it be like to walk on the moon? I'm sure many of you, including myself, have wondered this. Considering we haven't been back in almost 50 years, we may not be able to experience it for ourselves anytime soon. But I found a way to sort of piece together the experience. You see, last year when I flew 0G for the first time, the first few parabolas were in lunar gravity, making me feel 6 times lighter. So we got to do one-handed push-ups and bounce around and do the dramatic moonwalk you often think of. But another component of the moon we didn't get to experience, and that can be a big problem, is regolith, or that pesky moon dust that seems to get everywhere. In fact, it's the reason why researchers from all around the globe buy this very expensive simulant made here in Florida. In fact, Exlolith Labs makes all types of simulants from asteroids to Martian soil, but for this experiment, I got to walk on the moon. If only we could combine both the lunar gravity and the dust, then it would really feel real. But it was interesting to experience this for myself, and I can say moon dust is not the same as beach sand. Let me show you in this video. So we are here in front of the Exlolith Lab with Dr. Phil Metzger. I've met you many times online. This is the first time in person, so tell us what is going on behind the scenes here.
Well, hey, Ellie, really glad to have you here. And it's great to see you in person finally.
Yeah.
I feel like I've known you for a long time now.
I know, it's weird.
Yeah, so we're in front of the Exlolith Lab. This is a part of the University of Central Florida. This lab was started, I don't know how many years ago, 8, 9 years ago, as a proposal that Dan Britt and I wrote with Deep Space Industries to NASA to get funding to develop simulated asteroid soil. And Deep Space Industries eventually got out of this business, so they gave us the equipment, and it became the UCF Exlolith Laboratory.
Tell me, because I think a lot of people know the term regolith. What is Exlolith?
It means exo, like extraterrestrial or exotic, out in space. Lith meaning rock. So exolith would be soil or rock from outer space. And I guess it's a play on the word regolith, which means blanket of rock on a planetary body.
So what is like the goal of, the research here?
We still do our original scope, which was to invent regolith, simulated regolith for other planetary bodies. And that includes asteroids, the moons of Mars, Mars itself. So we do research to figure out how to make these simulated soils. Then we will identify sources like mines around the US. Some of the materials you can't get on Earth, and so for a while we were even trying to bake and make simulated minerals in gigantic pressure cookers, which was kind of scary. I used to call that machine the Kronstatite bomb. We were trying to make Kronstatite, and it was just like a big gigantic pressure cooker bomb that scared me. But so we still do that. We've now handed over the manufacturing and sales of the simulant to a company called Space Researches Technologies.
Okay.
But we also do research into soil mechanics, mining, extraction, rocket exhaust plume effects, everything that interacts with regolith on the moon or Mars.
Yeah.
All right, so this is the foyer, and this is one of the areas where Space Resources Technologies works. They're bagging up their simulant for sale, and they ship it all around the world. They actually do close to $1 million of sales every year selling dirt.
Yeah.
Can you believe that? $1 million per year.
So,
this is lunar mare simulant. The mare are the dark spots on the moon, and so this is more volcanic. It's has a lot of basalt and pyroxene. It's got the minerals that you would find in a lava flow. And then this is lunar highland simulant. This is like the light colored parts of the moon. And this has mostly feldspar. It's called anorthosite, as long as smaller amounts of basalt and ilmenite and other minerals. This is Mars global simulant. This is Jezero crater on Mars. So you can see there are a lot of different types of simulant that are available and are being sold commercially. Companies that are building technologies.
Yeah.
universities around the world that are doing research, and also educators that are doing classroom projects with younger students.
Wow. And I also saw this to the left here, some jars, and it also looks like some of this stuff is toxic, maybe a little dangerous to breathe in. So tell me about those warnings.
It is, yeah. It's not super highly toxic. Like the scale goes from 1 to 5, and it's usually classified around 1.
Oh, okay.
So it's classified as a nuisance dust.
Oh.
But honestly, I would treat it more like a 2, worse than just a nuisance dust. The problem is these minerals, like anorthosite dust, we just don't have a lot of experience. You know, there's not a lot of safety data.
Sure.
Because people haven't worked with this very much.
Right.
This is called CRATER. CRATER is an acronym, and I don't know what it stands for. CRATER, but it's a regolith bin. We believe it's the largest indoor high-fidelity regolith bin in the world. So this is the actual mixture of different minerals that you would find on the moon.
You said we could go in there?
Yeah, we can get you into a respirator and let you walk on the moon.
Let's do it.
Okay. I want to introduce to you Max Keene. He's one of the engineers here that runs the Exlolith laboratory.
And so what do we need to know before we go in there?
The particles that are in there are a little bit different than, say, what you would find in like the beach. So if you imagine over, thousands of years, you have these, rocks rolling over each other, and then that creates these kind of spherical particles. And then, so what happens there is, the interaction with sand is a bit, you can put your hand in it, it can move out of the way, it can displace. An interesting thing with this material is that the way that we produce it is very similar to the way that it's produced on the moon, and that's with just, high impact collisions and kind of cracking and breaking the particles down into very, very fine, I think 1 millimeter particle sizes, even smaller or bigger. In our simulant is a large mixture of ranges of sizes. So you have large or very large particles that can kind of make up, the overall structure. But what's interesting is when you have the very fine particles in between those, it makes it that much more cohesive, and you can kind of compact it. When it isn't compacted, it's very fluffy, and you'll almost kind of sink into it for a first few, millimeters or so. And even just kind of taking a step, you'll see dust, very fine dust kind of pop out from the sides of any gap in your shoe. The particles that we have in there are not good to breathe. So we will be putting some respirators on, and we can even put you in a bunny suit if you'd like to really get the whole experience.
Yes.
Yeah, sweet.
So why do we do that? I mean, obviously we want to have like the Rovers doing some practice in here, but why humans?
Yeah, I think there's a use case for, getting people to feel what their boots might do once you start. So obviously the main thing with the spacesuits that they're wearing is they're pressurized. And so what happens there is, honestly, walking is different, and bending down is different.
Right.
And all of those kind of mechanics, I think, would be worth testing.
Yeah.
What we can also do is eventually, in the future, one of our goals is to create a gravity offloading system. And so you load any payload onto it, calibrate it to remove 5/6 of the weight of whatever you put onto it. And you can then, if it's attached to our crane, for instance, you can move it anywhere in the bin, and then say you could put rovers on this system. They could test their wheels, make sure that the weight of the rover isn't making it easier to move, especially with Earth gravity. But then obviously, of course, another thing is you could probably do some touristy things or training for astronauts before they go to the moon.
Sure.
This is how it'll feel to step off of the platform. Can you guys do this?
Yeah.
And then they slip and they fall, and that's worth checking.
Yeah.
And the other thing is, as well as, just interaction with the simulant and placing equipment into the ground. So that was actually one of the recent customers of ours was Artemis 3, a piece of equipment that was going to be going on the Artemis 3 mission, and they needed to test how their gloves interacted with the simulant. Can we still grab the piece of equipment that we need and put it in the simulant and get the correct data that we're looking for?
So you had the Artemis astronauts in here?
Not the astronauts, man, but that would be awesome. But we had the people working on the team, which is almost the same amount of passion.
Have you ever filled it with like what it would be like on Mars, for example?
No, yeah, this is the first
Really?
iteration of this, and
How
of
old
ours.
is it?
So we finished it, I think, in about 2023. I think late 2023 because we needed it by 2024.
So it's new.
Yes. Okay. And then these right here are your different sizes. They're large, extra large, and double extra large because if you're too big for a bunny suit, you're gonna pop through it.
Yeah.
Which means it's not very useful.
Oh.
So yeah, true.
I feel like I'm in one of those Halloween costumes that's like an inflatable suit, sumo wrestler suit.
Or like the
Yep.
parking
with
lot.
a little fan in it.
Yeah.
Now, what happens if this were to get on your skin?
Nothing. It just dries it out over time.
Oh, okay. It doesn't hurt.
Yeah, if you're working with it over the course of a few hours, your hands will be dry if you haven't washed your hands.
Oh, got it.
Yeah, it just gets in the pores of your skin. When it is really fine, it will get in the pores. It's like talcum powder. I shouldn't admit this, but I have eaten it before.
Nice.
It didn't kill me.
Wait, why'd you eat it? On purpose or like?
Just to prove that I could.
Okay, beautiful.
Oh my god.
You're committed. This is
What's
for science.
going on? That's hilarious.
Whoa, so we got the gloves, we got that. So yeah, this, if once you put it down, it'll start to get foggy. So we'll turn this on real quick. So I'll press this button and then we'll let it power on. There you go.
Well, how does this work? This isn't like an oxygen tank, right?
It's just a filter, yeah. It's just an air
Oh, okay.
filter.
So I've never, I mean, this is weird.
Yeah, it's actually the reason you're hearing air right now is because it's a positive air pressure respirator. That's PAPR. So it's called a PAPR. Yeah, I was trying to figure out what the last word was, but it's just respirator. What it's doing is it is constantly blowing air into your helmet, and any gap that is near your face will push air out of it. So if there's dust outside of your mask, it will always have to overcome a very large force of air.
Got it.
And so that's it's a very similar kind of process to the clean rooms in medical hospitals and stuff like that. Quite a process, man, oh man.
It's like an astronaut. Just go?
Yeah, you're good to go. Go ahead and kind of, take your giant leap. Exactly, yes.
Can we touch it? Yeah, it just feels like really chunky sand almost. It feels slightly different to walk in than sand.
Kind of feel how it feels to dig with it is really what he's saying. There you go. You can just imagine. Yeah, there you go. That is the process.
Woo!
There you go, yeah. Woo! There you go, there's some plumes. So yeah, how does it compare to regular dirt?
I mean, it's like if you really grind it up, it definitely has more chunks in it.
Yeah.
And when you're walking, you can almost feel like a little cloud of dust.
Yeah.
But it's not crazy noticeable.
Yeah.
I think if we had the lunar gravity, then it would really be like, oh my God, every step is a big plume of dust.
Yeah, maybe, exactly. Because if you can imagine when a rocket is landing on the surface like this, all of this material is just going outwards. And what that basically means is if you have any sort of structure that you've built, you're just sandblasting your structures every time you land. And you need to land a lot. So this needs to be, dealt with. And so one of our solutions actually is to build berms, protective hills basically around the landing pads. And that is one of the most recent challenges that Lunabotics was solving is they had the rovers, start in a certain spot, make it to a pickup area, then you had to pick up stuff, some simulant and deposit it in a controlled area as well. And so if you could do all three of those, you were passing the test basically.
Oh.
But yeah, and all of that is for NASA to really explicitly look at the ideas that students are creating. Some of our designs have come from these competitions.
Yeah, like if you swipe your foot, like if you swipe it, it's kind of, you feel it. It almost feels like a magnet. It's like hard to describe.
It's really weird, yeah. It's like a suction force almost.
Ellie, I'd like you to try something. In the Apollo missions, they had these tubes they tried to shove down into the ground to pull out a core sample.
Okay.
And they couldn't get it to go in, so they redesigned it. On the next mission, they couldn't get it to go in again. The third time they redesigned it again, they finally were able to go into the ground.
Okay.
So I just want you to see how hard it is to shove something down into the ground. Try to shove it straight down. Try to shove that all the way down to where it's buried. You know, work it back and forth. It's so frictional, the soil is.
Yeah.
It's a lot harder than beach sand.
I'm putting my weight on it.
When it's compacted, it's extremely hard, but when it's fluffy, it's
Yeah.
extremely loose.
Right. I guess it'd be hard to bury someone on the moon. I feel like this is like an adult sandbox.
Yeah.
You know? That was really cool. I know, it's a little hot in those suits.
Oof, yeah, that's a sign that they're not letting anything into the suit.
Yeah, that they're working. But I was
Yeah.
laughing because now everyone's going to think that we were overkill because you were in there, you know, basically naked.
I mean, yeah, you know, I'm resilient to the moon.
Yeah.
No, I don't know. I think it's just, it's a...
It ruins the facade. I'll put like crazy music of us in the
Yeah.
suits and, you know, first
I'm an
steps.
alien.
And then you're like the camera crew.
a mutation or something,
Yeah.
I've gone in
You're
there
so used to
about
it.
30, times probably in this year so far.
Yeah.
And,
Sliding my foot sideways, I really noticed this weird, it was almost like a slippery floor.
yes.
But
Yeah.
then
you like float and then
exactly.
you get settled into it. Yeah. It's
Or like
really
even
interesting.
taking steps, sometimes it felt like there was a little like cloud of dust, but
Yeah.
it's hard to explain to just...
There's a technical term for what makes lunar soil so weird mechanically, and it's called the dilatancy. And the dilatancy of a granular material tells how much it can change in its compaction. So very compacted or very fluffy. And this material has an extremely wide range. So it can be as hard as sandstone. You felt how hard it was deep down.
Yes.
You can't even get a shovel in it. But when it's loose, it's like quicksand. And people will just sink in it. It's super fluffy. It makes clouds. It's slippery.
Wow.
And it'll be stable in any of those configurations. The reason rovers get stuck in that material is because of that dilatancy. Because when you're driving, the wheels are always shearing the soil.
Right.
And when you're shearing it, you're fluffing it. You're
Ah.
causing the dilatancy to happen.
Yeah.
You're making it expand.
And that was an interesting thing too, is that a lot of students are learning the difference nowadays between like the sand, beach sand, and the difference here, and especially when they bring their rover in from a few months of development, and they say they've been testing on their beach sand at their college, and then they start their run, and then they start digging themselves into a hole, and it's a really interesting. It's worth learning for them.
Yeah,
So,
I bet that is like such a
Whenever
bummer.
a team says they tested it on the beach, I think, oh no.
Oh no.
That's actually bad.
yeah.
Really?
It's like a beach sand, if you tilt it up about 35 degrees in avalanche, this stuff you can tilt it up about 65 degrees and it won't avalanche.
Yeah.
That's another problem. They'll dig the soil and then they'll go to deposit their soil to get the points, and it won't dump out of their road. You can't
Yeah.
get it to come out. You can see around here, these are 1-ton bags of different types of rock that are shipped in from all around the United States. So uncrushed basite, attapulgite, anorthosite. And so we'll buy these by the ton. This looks like anorthosite. This is already crushed. The white material is a calcium aluminum rich type of rock that is the primary, the most common rock on the light parts of the moon. That's mostly anorthosite. But they will buy the rock. Some of it comes crushed, some doesn't. Epsom salt, this is used in asteroids. There are certain types of asteroids that have those types of minerals. Okay, so let's go outside and I'll show you how they process it. Okay, these are ball mills. Those hard balls are used for crushing the rock. And some ball mills just shake. Looks like these are just tumbling ball mills. There are other types of rock that are too tough. You can't do this. So over here, there's crushers. So this is a grinder or a crusher. Some of these crushers, they'll have chains that they fling around, just regular steel chains that fling around and crush the rock up. But they'll catch it in these boxes. And then they have to mix them together in various ratios. So they'll measure out different amounts of each material and put them in these cement mixers and tumble them around to get them thoroughly mixed. So that's the process. Asteroids are a little more complicated because we would then wet the material and and dry it in baking pans to harden it into rock, and then crush it a second time. And that way every little particle will be a mixture of different minerals together, all in the right ratio. So they sell tons and tons of it every year. They ship tons of it around the world. Yeah, there's like 2 in the US, 2 or 3. This is by far the largest one. I think they have about 80% of the market from Exlolith Lab. And so they sell it to Europe and Australia.
Who are the key players that the Exlolith Lab is working with? I'm sure NASA.
Well, it changes, you know, whoever we win grants with,
Yeah.
and whatever companies want to give us a contract to support them.
Cool.
But I'll name some that we've worked with. We've done a lot of work with Blue Origin and with Honeybee Robotics, with Sysloon. We've done work with Redwire Space, and I've done some work with SpaceX. The problem we have in trying to develop lunar technology is that it's hard to do testing in the environment.
Yeah.
And you know, things, you think they work, but when you take them to another environment, to another
Right.
planet,
Right.
then the gravity is different, the atmosphere is different, the radiation's different, the thermal conditions, the vacuum, the dust, everything is different, the minerals. And so then your technology doesn't work. To solve that problem, we have to create the highest fidelity environment that we can,
Yeah.
that we can afford,
Right.
to do as much of the testing before the mission as we can afford to do. You're still going to have problems when you get to the actual moon. You know, everybody says space is hard, and it is. It's exotic, and technology has to be matured
Yeah.
before it becomes reliable, and it has to be matured in that environment. But we can get the reliability a lot higher by simulating the environment as close as possible. I'll tell you a little bit about the Stephen Hawking Center if you're interested.
Sure.
Yeah, the Stephen Hawking Center, we have the goal of creating a global program that will democratize space to get people all over the world involved in space, developing technologies and starting businesses. But it's not a business, it's more, we're trying to create a global movement. And Stephen, when he was alive, commissioned UCF to start this. He commissioned the Stephen Hawking Center. Took us a while to get it through the legislature, so that's why you haven't heard about it before. But it's now official, and we're getting ready to have our grand opening soon.
So thanks so much to Dr. Phil Metzger and of course Max for giving us this exclusive tour. It was an experience that I will never forget and something that I hope you guys really enjoyed seeing for yourselves. I really love making these more in-depth education videos with experts, so if you liked it as well, please make sure to subscribe to my channel. It's completely free and you don't want to miss any videos in the future. Thanks so much for supporting Ellie in Space, and I'll see you in the next video.